Today we're going over segment relationships in circles. So our first theorem discusses when two chords intersect and what happens with those four segments to know their relationship. So when two chords intersect inside of a circle, then the product of the lengths of the segments of the chords are equal. So what that means, segment AB times segment, or segment A times segment B, they're on the same chord, equals segment X times segment Y. Again, X and Y are on the same chord. So we're going to do that now. So 8 times X equals 6 times 5. Please note 8 and X on the same chord, 6 and 5 on the other chord. So we've got 8X equaling 30, dividing by 8. So X equals 3.75. Our next one, an archaeologist discovered a fragment of an ancient disc to calculate its original diameter. They drew a chord, AB, and its perpendicular bisector, segment PQ, find the disc's diameter. So the diameter goes all the way across through the center, which is segment PR. That is what we are looking for. Its length. So perpendicular bisector makes a right angle because it's perpendicular, which you see in the picture. And it's a bisector, meaning that it cuts segment in half. So this is also 5. And we're looking for this length. So we have 3x equaling 5 times 5. So 3x equals 25. Dividing by 3. And x equals 8.33. However, this is not my final answer because we're looking for the diameter, not just a piece of that chord. So now, to find the length of PR, we need to add 8.33 and 3. And that gets us 11.33 inches. So next up, we are going to talk about secant segments. So remember that a secant is a line that goes through the circle, meaning that it touches the outside of the circle twice because it's going through it. And a secant segment is just a piece of that line. And the interior secant segment is the part of that segment that is inside of the circle. It's in the interior of the circle. So we've got a theorem with two secant segments. It says that the outside piece of a secant segment times the entire length of that segment, what's that? B times A, equals to the outside of the other secant segment that is intersecting the original one times that whole secant segment. So y times x. So when you're doing secant segment problems like this, you need to know that your outside is one part, and then you need the whole length. Remember, to find the whole length, you are adding those two numbers. So 4 plus 6 is 10. And 5 plus x is 5 plus x. So again, it's outside times whole. So 4 times 10 equals the outside times whole in the other segment. 5 times 5 plus x. So 4 times 10 is 40 equals 5 times 5, which is 25, plus 5 times x, which is 5x. Subtracting 25 from both sides, and we get 15 equaling x, or equaling 5x, sorry. Then we're going to divide by 5, so we get x equaling 3. Okay, other things to remember, that when you have a tangent or a segment of a tangent that goes from the point of tangency to an intersection with another tangent segment, that these two lengths are congruent, they're equal to each other. So again, these are tangent segments. They're pieces of a tangent line, which touch circled at one point. So now we have a theorem that involves one secant segment, so that's this, and one tangent segment. So this one says that the outside of the secant segment times the entire length of the secant segment equals the tangent segment length squared. So in this case, that would be B being the outside times A being the whole, equaling x squared. Our next one uses that theorem. So we have the outside, which is 4, times our whole length, which is 9 for our secant segment, equaling our tangent segment squared, x squared. 4 times 9 is 36, equals x squared. Remember, to get rid of the square, you take the square root. So we've got 6 equaling